We recently did a frequently asked questions video where we mentioned that James, our master of microscopes, was on the lookout for a super rare ciliate with retractable tentacles called Thysanomorpha. This video is not a surprise announcement that we've found one. The Thysanomorpha remains elusive for now. But it turns out that Thysanomorpha is not the only super rare ciliate with retractable tentacles. What you're looking at right now might not immediately stand out. You got a sea of green organisms, and then in the middle is a clearish oval. And that oval is what we're going to talk about today, because over the course of 3 years, James's many excursions into different watery sources have turned up only 3 of them. And as rare as the species is, we think the footage he's taken might be even harder to come by. The organism is called Actinobolina, and it showed up in a paper that a ciliate scientist sent to James titled Protozoa of Especial Interest from Van Cortlandt Park, New York, written by Gary N. Calkins. The paper was an old one published in 1901, and if you haven't been able to tell yet, we love old papers like this. They've often been written in a way that feels a lot more casual than the way academic papers are structured today. It can feel like you're just reading somebody's journal entry or a travel blog that just happens to contain important biological insight. Calkins' paper even starts with an extended description of Van Cortlandt Park, complete with railway directions and instructions on how to reach the exact pond he sampled from. So James read this delightful paper, which includes an extended passage of the Actinobolina in action, and the next morning, he found one. We mentioned that he's only found 3 Actinobolina in 3 years. This is the 3rd one, found the morning after reading Calkins' paper. When James observed his first Actinobolina, he didn't yet know how rare they were, and his second Actinobolina died quickly, likely due to some kind of temperature shock. So with this 3rd member of the species, James made sure to take extra care to keep it alive and follow it around so he could observe it as much as possible. Now, what makes Actinobolina so notable are the tentacles lining its body. They can be a little difficult to make out from far away, but you can see the faint lines of them surrounding the body. With great magnification, though, you can start to see the bundles of cilia and tentacles a bit better. The tentacles can reach to around 2.5 times the length of the organism's diameter when fully outstretched. But even more cool than how far the tentacles go out is how far in they go. Like when the Actinobolina needs to move around and doesn't want some cumbersome extensions getting in the way. And when it's zipping around the microcosmos, the Actinobolina's cilia seem to have more of a vibration to them than the usual wave-like stroke associated with cilia. In fact, they kind of resemble flagella more than cilia, but we don't know much about why or how this movement works. In his description of Actinobolina, Calkins writes, "It is when the animal is quiet that it takes in food. It remains for hours sometimes without giving any sign of feeding, but the tentacles are stretched out to their greatest length, and it appears merely waiting for something to come." We don't know if he meant for it to sound as ominous as it does, but it certainly feels appropriate for a tentacled predator. Part of the fun of reading these old papers is getting to see how well these observations made by scientists over a century ago match up to what we can see now. It's like exchanging letters with the past, and our little Actinobolina is the courier. And it's all even more exciting for us in this case, because as far as we can tell, not many people have gotten footage of the Actinobolina in the midst of a hunt But while Calkins may not have had the technology we have today to capture what he saw, he did provide detailed descriptions that line up nicely, starting with the surprisingly particular tastes of the Actinobolina. Organisms pass and pass, but nothing tempts the hunter, until a specific prey comes along, the unsuspecting ciliate called Halteria. The Actinobolina stabs it with a tentacle, which is loaded with a toxicist at the end to immobilize the prey, and then the tentacle draws the food in to its inevitable end. The Actinobolina digests its meal, but as Calkins himself said, it is insatiable, so it retracts its tentacles and leaves, seeking out a new spot to stretch out and ensnare its next meal. And here it is again, catching another Halteria with its tentacles. Using the word tentacle makes the Actinobolina sound like an octopus, but watching the hunt in action, it looks more like a porcupine with its quills fully extended, but a porcupine that uses its quills to skewer meals instead of protect itself, and then it retracts the quills so it can rush on to the next spot. We might be testing the limits of our comparisons right now, but that's okay. According to our calculations, we've got about a year until we see our next Actinobolina, so when that rolls around, we'll be ready with some new ones. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. And thank you, as always, to all of the people on the screen right now. These are our patrons on Patreon, and right now, we're pushing to get to $5,000 a month, which is when we'll be getting a brand new objective. That's a lens for the bottom of the microscope for our DIC microscope. If you want to see more from our master of microscopes, James Weiss, check out Jam and Germs on Instagram. And if you want to see more from us, there is always a subscribe button somewhere nearby.